All right, for this question, it says a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Part A asks, how much money will he make if he sells 75 machines? And if he wants to bring home an annual income of $120,000, how many machines must he sell? So for this, I look around and I don't see any percentages. So the rate of change is not a percentage this time. And that means we are most likely dealing with a linear equation, not an exponential. Now your linear form is completely different from your exponential form. It's going to be y equals m multiply x add b. So let's make a list of the letters. M, X, B, Y. So M is going to be our rate of change. Now this isn't always easy to find in the wording of the question because each question is written differently and it's not always a simple matter to pick out which number should be the rate of change. So when you are trying to locate the rate of change, look for certain words. You want to look for per, each, or every. Usually the rate of change will be located nearby. Now, in this question, I notice they have the word every machine here, and the number located next to that is 300. So I'm going to call that my M. And so we'll go to the M box and say 300. Notice it says plus, so that is a clue that this will be a positive number. Now for x, this is our independent variable. To decide what this is, we want to look after the per, the each, or the every. So that's going to give us a clue about the meaning of x. So I see that after the word every, we have the word machine. That tells us that the number of machines is going to be the x value. Let's write that down so we don't forget. Now, part A asks us, how much money will he make if he sells 75 machines? So x is given to us. It's not in the same place as everything else, but it is there. So next to x, we place 75. Now for B. B is our initial value. Now this isn't always easy to see either, but there is a number that we have not used yet. And that's going to be this number, the base salary. That's the money we make for coming to work. That's going to be our B. And so we'll place 40,000 in the B box. Now y is going to be our new value, also called the dependent variable. Now, the dependent variable is called dependent because it depends on the x. So as x changes, that causes y to change. So in the y box, let's enter our linear form here. We'll say equals m multiply by x add b. If we press enter, we find that our new salary, if we sell 75 machines, is $62,500. So that takes care of part A. Now for part B. If he wants to bring home an annual income of $120,000, how many machines must he sell? So if we have a look here, if they're telling us an amount of money, we are given a y. But anytime you're given a y, we have to use goal seek to find the answer. Our goal is to make the y into 120,000, But again, we can't just type that in manually. What we have to do is make a copy of what we've already done. Now, our target is to make the y into 120,000. So we will goal seek the y to $120,000. First, we click on the y, the 62,500 that's there that we intend to change. We go to Data, What If, Goal Seek. In the middle box, we place $120,000 by changing the cell that it depends on. But as we've said, it depends on the x. So we click the number next to x and press OK. So once we press OK, the y changes to the correct number, and the x becomes 266.667. This is going to be our answer. So, to make $120,000, we must sell 266.67 machines. Now, of course, you can't sell 0.67 of a machine, so let's go ahead and round up and say 267 machines. So there you have it. We've answered question B. That's how many machines we have to sell to make that amount of money.